Good morning, all of you. In this session, I am going to explain about resolution of inclined forces. In previous class, already I explained about how to determine resultant for coplanar collinear forces and coplanar concurrent forces. These are the examples for coplanar collinear forces. These are the examples for coplanar concurrent forces. These are the examples for coplanar parallel forces. This is the example for coplanar non-concurrent, non-parallel, that is general forces. Okay. In last session, I explained about the collinear forces and parallel forces. Okay. And resultant is the replacing the system of forces and couples acting on a body to a single force having the same effect. Okay. Already I explained about this topic in last class. So already we discussed about these problems, how to add the horizontal forces and vertical forces. Okay, I completed these topics in yesterday class. In this session, I am going to explain about a new topic, that is a resolution of forces. By using this concept, we learn how to convert a inclined force into horizontal and vertical component. A single force vector is replaced by two or more forces having the same effect is called resolution of forces. Okay, here for example, here this is a single force. Okay, this single force vector is replaced by two forces having the same effect. Okay, this procedure is called resolution of forces. Here I am applying a pulling force. Okay, I am applying a pulling force at point A. Okay, at an angle theta with respect to the x-axis. Theta is the direction of the force. Now here I want to convert this single force vector into two force vectors, that is horizontal force vector and vertical force vector. I want to convert this inclined force into horizontal force and vertical force. Okay, these are the examples for resolution of forces. I will explain one by one. Here, this is a first quadrant. If a force is lying in first quadrant, here you can observe the force F. F is the magnitude of the force. Okay, the force vector F is acting at origin, and the direction of this force is theta with respect to the x-axis. Okay, now here you have to convert this inclined force into horizontal and vertical force. Okay, you have to split this inclined force into two forces. I will explain in this session. Listen carefully. First, you have to consider x-axis and y-axis. Okay, this is x-axis and this is y-axis. Okay, the x component horizontal force lies on x-axis. Okay, vertical force always lies on y-axis. Okay, so I am drawing a horizontal line for considering the x component, that is horizontal force. Okay, this is horizontal force. Here the force is acting away from the origin. Okay, this force is acting away from the origin. Okay, the force is started at origin. Okay, goes like this. That's why I am taking x horizontal component like this. Okay, now the magnitude of this horizontal force is equal to the force into cos theta. Here, this is the adjacent side. Okay, adjacent side to this angle. Okay, so for adjacent sides, you have to consider cos theta. Okay, so the value of the magnitude of x horizontal component is force into cos theta. Okay, here the positive sign for horizontal force towards right. If a force is acting along the x-axis in right side direction, then you have to consider positive sign. Okay, if your force is lying on x-axis and towards left, then you have to consider negative sign. Okay, now this is the answer for horizontal force. Now in similar way, you have to convert this inclined force into vertical component. Then you have to take y-axis for determining the vertical force. The vertical force lies on vertical axis. So that's why I am drawing a force like this. Now the magnitude of this vertical force is equal to the force into sine theta. Okay. So here this force is opposite to the angle. So that's why I am taking sine theta for opposite sides. Okay. Now here positive sign for vertical force towards upward, towards up by the positive side. Okay, so here I am converting this inclined force into horizontal and vertical forces. Okay, in similar way, coming to the another example, this is x-axis and this is y-axis. Here the force acting on a origin with angle theta. Okay, now you have to convert this inclined force into horizontal and vertical forces. Okay, for determining the horizontal force and vertical force, you have to draw x-axis and y-axis at the origin. Okay, here the x-axis. Okay, the horizontal force lies on x-axis. The value of this horizontal force is equal to force cos theta, force into cos theta. Okay, because this force is adjacent to the angle, so you have to consider cos theta, and this force acting towards left, so you have to consider negative sign from these sign conversions. Okay, if a force is acting towards left, then you have to consider negative sign. Okay, this is the magnitude of horizontal force. In similar way, I am drawing a vertical force on y-axis like this. Okay, then the magnitude of this vertical force is equal to force into sine theta. Okay, so here this vertical force is acting towards downward, so you have to consider negative sign for downward direction. Okay, this is the answer for this example. Now coming to the another example. Now the force F is acting on the origin, and the direction of this force is angle theta with respect to the y-axis. Now how to convert this inclined force into horizontal and vertical force? First you have to draw a horizontal line for horizontal force. Okay, the magnitude of this horizontal force equal to force into sine theta. Here angle made with the vertical axis. So this force is opposite to the angle. So you have to consider sine theta for opposite sides, and for adjacent sides you have to consider cos theta. Okay, here this force is acting towards right. That's why you have to consider positive side. And this is the vertical force. Okay, the magnitude of this vertical force equal to force into cos theta. Okay, for adjacent sides you have to consider cos theta. For opposite sides you have to consider sine theta. Okay, now coming to the another example. Here the force is acting like this. Then how to convert this inclined force into horizontal and vertical? Here this is the x horizontal force. The magnitude of this horizontal force equal to minus f sine theta. Here this force is acting towards left. That's why I am taking negative sign. And this force is opposite to the angle. So here I am considering sine theta for opposite sides. In similar way, I am drawing vertical force like this. Okay, here this vertical force is acting towards down. Then the magnitude of this vertical force equal to minus f cos theta. Okay, for adjacent sides you have to consider cos theta. Okay, here negative sign for downward direction. Okay, negative sign indicates downward direction. Here this negative sign indicates left side direction. Okay, coming to the another example. If a force is acting like this, the direction of this force is theta with respect to the x-axis. Then how to convert this force F into horizontal and vertical? Okay, the horizontal force lies on x-axis like this. The magnitude of this horizontal force equal to F cos theta. Okay, this is adjacent side. So I consider cos theta for adjacent side. Now the value of a vertical force lies on vertical axis. Okay, so this is the vertical force. The magnitude of this vertical force equal to F sine theta. Okay, this force is opposite side. For opposite sides you have to consider sine theta. Okay, this force is acting towards down. That's why I am taking negative sign for downward direction, positive sign for right side direction, and negative sign for downward direction. Okay, another problem, another example. If a force F is acting like this, the direction of this force with respect to y-axis is theta. Then how to convert this inclined force into horizontal and vertical force? Yeah, this is horizontal force. The magnitude of this horizontal force equal to F sine theta. Okay, here the angle is with respect to x-axis. Here the angle is with respect to the y-axis. So here this is the opposite side. That's why I am taking sine theta. Okay, this force is acting towards right. For towards right, you have to consider positive sign. For vertical force, you have to consider like this. This force is adjacent side to the angle. So cos theta for adjacent sides. Negative sign for downward direction. Okay. Now this force is lying in third quadrant. Then how to convert this force? Here this force F is making angle theta with respect to the x-axis. Then you have to draw a horizontal line for horizontal force. This horizontal force having magnitude F cos theta. negative sign for left side direction. Okay, for left side direction, you have to consider negative sign. Okay, now this is the vertical force. The magnitude of this vertical force equal to minus F sin theta. Okay, this vertical force is opposite to the angle, so that's why I am taking sin theta and a negative sign for downward direction. Last example, here the force is acting towards origin. Then how to convert this force? Draw a horizontal line for horizontal force. Okay, this is a horizontal force. The magnitude of this horizontal force equal to F cos theta. Okay, here this force is acting towards right, so you have to consider positive sign. And this is a vertical force. The magnitude of this vertical force is equal to the F sin theta. Here this force is acting towards up, that's why I am taking positive sign. Okay, so these are the some examples for resolution of forces. By using this concept, I am going to explain some simple problems. This is a given problem. Okay, here three forces are given. These three forces are acting at a common point. Okay, that means these three forces are concurrent. These three forces are concurrent forces. Okay, here this is a horizontal force, this is a vertical force, this is a inclined force. Okay, yeah, the question is resolution of forces into x component and y component. You have to resolve these three forces into horizontal component and vertical components. Okay, this is a given diagram. I am converting this diagram into horizontal and vertical forces. This is horizontal and vertical axis. Okay, this is x-axis, this is y-axis. Okay, here I am taking horizontal force as it is. Okay, now I am taking this vertical force as it is. There is no need to convert these horizontal and vertical forces. Now you have to convert this inclined force into horizontal and vertical force. From previous lectures, by using those formulas, you have to convert this inclined force into horizontal component and vertical component. Here the magnitude is 100 and angle is 30 degrees. So by using these two values, you have to convert horizontal and vertical forces. Okay, from previous lectures, already explained about this concept. Here, a force is acting away from the origin, okay, with angle theta with respect to the x-axis. Then the force, this horizontal force is F cos theta, this horizontal force is F sin theta. Okay, these are the magnitudes. In similar way, here this is the inclined force 100 newtons equal to F. Okay, now the value of horizontal force equal to F cos theta. So I am drawing here, this force is acting towards right. So I am drawing horizontal force like this. The value of this horizontal force equal to F cos theta, that is 100 cos 30. Okay, theta equal to 30 degrees, F equal to 100. So 100 cos 30 is the horizontal force. And vertical force is F sin theta, like this. 100 sin 30 is the vertical force. Here I converted this inclined force into horizontal and vertical forces. Okay, so from this diagram, you have to add horizontal forces like this. Okay, you have to consider positive sign for right side direction. For negative sign, you have to consider left side direction. For upward direction, you have to consider positive sign. For downward direction, you have to consider negative sign. Okay. Here, force 70 newtons. This is the first force. Take any order. Okay. Take any order. You can start from anywhere. Second force is 50 newtons and third force is 100 newtons. Okay, angle 70 newtons having 0 degrees, 15 newtons also 0 degrees, 30 newtons force making an angle 30 degrees with the horizontal. Okay, now from this diagram you have to note down horizontal forces and vertical forces. This is the x component means horizontal forces, y component means vertical forces. Okay, y component means vertical forces, x component means horizontal forces. Okay, so here you can observe 70 newtons. This 70 newtons force lies on x axis. So this force having only x component. Okay, this force is acting towards left, so you have to consider negative sign. So minus 70 is the answer, and y component is 0. Okay, for 15 newtons force, this 15 newtons force is acting towards down. Okay, that means this 15 newtons force lies on y axis. That's why you have to consider y component. Okay, for downward direction, you have to consider negative sign. Okay, and the x component is 0. Okay, for 100 newtons force, this is the x component, this is y component. Okay, this x component is acting towards right. That means a positive sign for right side direction. So plus 100 cos 30 is the x component, and this one also positive sign, plus 100 sin 30 for y component. Okay, this is the answer for this problem. Okay, these all are x components, these all are y components. Okay, now coming to the another example. This is the second problem. Okay, now here also I am considering three forces. Okay, here I want to convert this 100 newton force into horizontal and vertical component. This is x-axis, this is y-axis. Now I am taking horizontal force as it is, vertical force also like this. Here you have to convert this inclined force into x component and y component. This force lies in second quadrant. So take second quadrant formula. Okay, from this formula, the x force, this is a horizontal force, this is vertical force. Okay, the value of horizontal force is F sin theta, and the value of vertical force is F cos theta. Okay, draw a horizontal force like this. Okay, draw a vertical force like this. Okay, here the opposite side is horizontal force and adjacent side is vertical force. For adjacent sides, you have to consider cos theta. For adjacent sides, you have to consider cos theta. For opposite sides, you have to consider sin theta. Okay. Now, you have to consider sine conversions. Okay, you have to follow these sine conversions. Okay, these are the forces, given forces. These are the given angles. Okay. Now 70 newtons force lies on x-axis. That's why this 70 newtons force has only x component. Okay, plus 70. For the right side direction, you have to consider positive side. There is no y component for 70 newtons. And this next force is 50 newtons. This 50 newtons force lies on y-axis. Lies on y-axis. That's why you have to consider y component only. Okay, so this force is acting towards down. So minus 50. Minus sign indicates downward direction. Okay, minus sign indicates downward direction. Minus 50. And x component is 0. Okay. Now this 100 newtons force, I converted this 100 newtons force into x component and y component. This 100 newtons force having two forces, x component and y component. So this x component lies on x-axis, y component lies on y-axis. Okay. Now I am considering this horizontal force 100 sine 40 for x component. Negative sign indicates direction. For left side direction, you have to consider negative sign. Okay. Now this is a y component 100 cos 40. Positive sign indicates upward direction. Okay. This is the answer for this problem. Now coming to the last example. Here you can observe three forces are acting at a common point. Here one force is vertical, other two forces are inclined. Okay, how to convert these two inclined forces into horizontal and vertical forces? First you have to draw horizontal and vertical axis. Now I am drawing this vertical force as it is. Here I want to convert this 70 newtons force into horizontal and vertical forces. This 70 newtons force lies in second quadrant. Okay, that's why I am taking second quadrant formula. Okay, this force is F equal to 70 newtons. Now this is the horizontal force, this is vertical force. Okay, for adjacent sides you have to consider cos theta. For opposite sides you have to consider sin theta. Okay, with respect to this angle you have to consider opposite side and adjacent side. Okay, from this equation, the x horizontal force for 70 newtons is like this. Okay, minus F sin theta. F equal to 70 newtons, sin theta equal to 40 degrees. So sin 40, 70 sin 40 is the horizontal force, and vertical force is 70 cos 40 degrees, like this. Okay. Now I am drawing this vertical force as it is. There is no need to convert this vertical force. Okay. Now I am going to convert this inclined force 100 newtons force into horizontal and vertical forces. Okay, this 100 newtons force lies in first quadrant. So I am considering first quadrant formula. Okay, Here the force F equal to 100 newtons and angle theta equal to 30 degrees. Okay, this is the horizontal force, this is the vertical force. The magnitude of this horizontal force equal to F cos theta. F is the 100 cos 30 degrees, and this vertical force is F sin theta. F is 100 sin 30. Okay. If a force is acting towards right, then you have to consider positive sign. For upward direction, you have to consider positive sign. For downward direction, you have to consider negative sign. Okay. So this horizontal force F cos theta equal to 100 cos 30 acting towards right, and this vertical force F sin theta equal to 100 sin 30. Okay. So from this diagram, you have to calculate horizontal and vertical forces. Okay, these are the sine conversions. These are the given forces. These are the given angles. Okay. Now 70 newtons. 70 sin 40, 70 cos 40. These two are the horizontal and vertical forces for 70 newtons force. So this is the horizontal force, 70 sin 40. Okay, this force is acting towards left. So for towards left, minus sign. You have to consider minus sign. And this is the vertical force plus 70 cos 40. For upward direction, you have to consider positive sign. Okay. Now, second force is 50 newtons. This 50 newtons force lies on y-axis. That's why you have to consider only y component. Okay. Other component is 0. Okay. For downward direction, you have to consider negative sign. Okay. From these sign conversions. Now 100 cos 30, 100 sin 30. These two are the forces for 100 newtons force. This is the horizontal force. This is the vertical force. So 100 cos 30 is the x component. 100 sin 30 is the y component. Here positive sign indicates horizontal right side direction and upward direction. Okay. So this is the answer for a given problem. Okay. Okay. In next class, I will explain how to determine a resultant force for these forces. I will explain in next class. Okay. How to determine resultant, magnitude of resultant and direction of resultant for these forces. I will explain later. Okay.